Welcome to Learn Yourself. Today we are going to understand the concept of mass and weight, and we will see that how the weight will change as the place, planet and surroundings will change. Even on the earth, at the equator and at the poles, the weight will change. So we are going to discuss all these topics under CBSE Standard 9 syllabus from chapter 10. So what is a mass? Mass is a constant quantity attached with the body. It will never change as the place will change. So mass will remain same at any place, whether you are on the earth or at any other planet. The mass will remain always same. From the previous chapters we know that greater the mass, greater the inertia. As mass is more for the object, the inertia will be more for that object. So this is all about mass. That mass is never going to change whether the condition or the place will change. Mass will remain constant. But weight is something different from the mass. Weight will change according to the gravitational force will change. If the person is on the earth, its weight is more. But if the person is at the moon, its weight is less. Why? Because Earth's gravitational pull or force is more compared to moon. Moon's gravitational force is less, so person's weight is also less. So as the gravitational force for that place is more, the weight will be higher side. We know that F equals to ma, mass into acceleration, which will give us force. We know this also, that F equals to mg. G is acceleration due to gravity. So force equals to mass into acceleration due to gravity. The force of attraction of the earth on the object is known as weight of the object. Actually, what is a weight? Whatever force is acting on the object due to the gravitational force of the earth, that is known as weight of the object. And as per this definition, this force is a weight because the force which is acting on the object, and that is that force of attraction of the earth which is acting on the object, is known as a weight. So this force of attraction, so this force we are taking as force of attraction. So this is going to be W because that is weight. Force of attraction of the earth which is acting on the object is known as weight. So here this force we have replaced with the W, which is weight. So W equals to m into gravitational pull. So this is our new formula, that weight equals to m into g. Now what is the value for g? G is 9.8 meter per second square. What is a weight? The weight of an object is the force with which it is attracted towards the earth. It is the force by which it is attracted towards the earth. So weight equals to force acting downwards, because this gravitational force is always acting towards the earth which is at the downward. So this is force acting towards downward. It has both magnitude and direction. That magnitude means it has one specific physical quantity, and direction because it is acting towards downward. So it has a direction that it is acting towards downward. So that direction, and magnitude means it has one certain physical quantity which will tell us that this much is the weight. So weight has both magnitude and direction. Then W is proportional to m. Weight is directly proportional to object's mass, because always mass we are taking as a measure of the weight. Weight of an object is a measure of its mass. So W is proportional to m. As W will increase, mass will also increase, and vice versa. We know that W is equals to mg. So weight is depending upon the g. Weight is depending upon the g because mass will remain constant. Mass will not change from place to place. It will remain constant. Whereas g, which is acceleration due to gravity, will change from place to place, and it will different at equator also, and it will different at poles also. So as the g will change, the weight will also change. So weight is also depending upon the g. Whereas it is depending upon the mass, but mass is a constant quantity. So as g is differing, the weight will differ. Now let us understand how the weight on the moon is 1/6 time than that of on the earth. So we know this equation that W equals to m into g. W is weight, m is mass and g is acceleration due to gravity. We also know that g equals to capital G, m that is mass of the earth and r that is radius of the earth. So this is also a formula that small g equals to capital G, mass divided by r square. R is radius of the earth. So when we are putting this value, this g's value in this equation, so we will get another equation that is W weight equals to mass into capital G into m divided by r square. So this is our new formula and this we are going to use to calculate the weight of an object on the earth and weight of an object on the moon. Weight of earth is this much, weight of moon is this much, radius of the earth is this and radius of the moon is this. Now we are substituting all this value in this equation. So first we are calculating for the earth, that earth's weight and earth's radius we are substituting in this equation, and later we are taking these two values and we are substituting in this equation. By doing so we will get two different weight on the earth and weight on the moon. So here weight on the moon is this, that here we have replaced this capital M's value, that mass of the moon, that here mass of the moon is 7.36 10 raised to 22 divided by radius, that is 1.74 into 10 raised to 6, and mass small m we are keeping it as it is because later on it will eliminate, and g also we are keeping it as it is because later on it will be eliminate. So this two constant we are keeping it as it is, and we will get here 2.431 10 raised to 10 capital G into small m. Same way we are calculating weight on the earth. Here we are putting mass of the earth and radius of the earth, that square. So we will get answer 1.474 10 raised to 11 capital G into small m. Now let us take a ratio of the weight on the earth divided by weight on the moon. So we are substituting these two values in this equation, and both of this capital G and small m will get cancelled here, and we will get answer 0.165, which is almost equals to 1 divided by 6. This is decimal. When we are converting it into fractional form, it is 1 divided by 6. That means WE divided by WM equals to 1 divided by 6. Weight on earth divided by weight on moon equals to 1 divided by 6. This we can also write like this, that weight on earth equals to 6 times the weight on the moon. For example, if the weight on the earth is 1 kg, then here on the moon the weight will be 6 kg, the 6 times higher. Here weight on the moon equals to 1/6 into weight on the earth. So both the ways it is true that whatever weight, if there is a 6 kg weight is there on the moon, then it is only 1 kg weight we can see on earth. So this is the relation between earth's weight and moon's weight, and this is due to the gravitational force, as earth's gravitational force is more and moon's gravitational force is less.